Hi, everyone. Great to see so many of you here today. I hope you're as excited as I am to talk about how to prevent fraud today. I would like to kick things off with two questions to you. First question: how many of you think that fraud is a considerable issue in your business today? Please raise your hands if you do. Quite a few, and you're probably right. So there's a study made that about 5% of annual revenue is lost for the average business due to fraud every year. So imagine if you could just get that down by 0.5%, what would that mean for your business? Second question: who of you thinks that fraud will still be an issue 5 years from now? Please raise your hand. Okay, the majority, and unfortunately, I think that is the truth. Fraudsters continually update their patterns and their ways on how they will try to get something for their own, right? And hopefully, in this talk today, we will show you another tool how you can stay ahead of fraudsters in your business. My name is Johannes Lange. I'm a solutions architect here at AWS. With me today, I will actually have two speakers, Georgios Drakos, who is a prototyping architect at AWS, and also a special welcome to Micha Zeleznica, who is enterprise architect at DB Systel. And he will share his story, how Deutsche Bahn actually took on the fraud challenge in their online payment system. All right, so let's get started, and let's talk about what fraud actually is. So I found a definition on the Oxford Dictionary, and it mentions fraud is the wrongful or criminal deception intended to result in financial or personal gain. Okay, what does that mean, right? So let's put that a little bit in context, and especially in our business context. What I want to talk today about is online fraud, or at least I would like to focus about online fraud. And there are a couple of ways. And to make that a little bit more tangible, let's all imagine we have our own online business. Let's say you're a retailer, you're selling shoes online. What are some typical patterns that fraudsters use or try to gain something for their own ways, right? So one pattern could be they will try to take over the accounts of your customers, right? So there are a couple of ways, social engineering being very popular, but there are more than that. And then they will make the purchases on their behalf. And obviously, you as a retailer will have a sad customer for once and probably lost revenue. Another, a second very good pattern that they are trying to use is just simply using stolen payment credentials. And that's actually something that we will focus on today. So they are trying to get credit card credentials and then make purchases with those. So the question is, how can we prevent this? I mean, there are a couple of measures you can put in place from a security perspective, but probably you will not catch all of them with that. So one of the challenges then is, okay, if we want to prevent this, what is the first thing that we have to do? Yes, we actually have to detect fraud, right? So we have to build a fraud detection system, and a fraud detection system in its essence is actually pretty simple. So let's see how traditionally fraud detection systems were built. So there are kind of three components. So we are looking at a fraud detection system for online transactions. What you would need as a first step is an input into the system, and that would typically be some information about the transaction. So what could that be? Stuff like, okay, what are the wares that person purchased? Who bought it? What is the account? What is the client that he or she used, right? So all of those things that could possibly influence the decision whether a transaction is fraudulent should go into the system. So that is something that you have to do, and there's also a challenge, where do you get the data? But let's say you have the data. The second step then is come up with a set of rules in order to, based on those inputs, decide whether a transaction is fraudulent or not. What a lot of companies are doing, they are hiring fraud experts who then skim through existing fraudulent transactions to figure out some kinds of patterns. And then somebody has to code those rules into a system. And in the end, the system hopefully has a set of good rules and takes the decision to say, okay, this transaction is fraudulent or not. Sounds easy, right? Not so fast. So it can quickly become challenging. Those rules are usually static, so you would have to update them constantly. As I said, fraudsters are not sleeping. They are constantly trying to find new ways to get around your system and your rules. So you have to update them. Somebody has to do that. And as you can imagine, the longer the system is in place, it gets more and more complicated, and it will be even harder to scale. So there must be a better way. And to show you a better way, I would like to welcome Georgios on stage. Georgios, the stage is yours.
Thank you, Johannes. Hello, everybody. How are we doing today? Good? So, as Johannes mentioned, fraud detection systems with rule-based are complex and difficult to scale. They simply rely on a static set of rules and can miss complex fraud patterns. So, you might be wondering if there is a better solution. And the answer to that question is yes, by using machine learning. So, machine learning fraud detection systems have three main superpowers. First, they're able to detect complex fraud patterns by analyzing a vast amount of data, while a rule-based system might miss. Rule-based systems are based on humans that will manually analyze the data, so they might miss some complex rules. Secondly, machine learning systems, they continuously analyze new data and then come up with new rules and learn from them. So this means that the rules that they come up, they can continuously be adapted and be learned and identify new fraud patterns as soon as they occur without any delay. This is really important because fraudsters, they continuously adapt their techniques. In traditional rule-based systems, domain experts are first needed to analyze the new data and then come up with new rules. This can be both time-consuming and costly. And lastly, a lot of you might have experienced the operational overhead of managing rules. In rule-based systems can become quite unmanageable as the number of rules increases. Machine learning systems, on the other hand, are better equipped to scale as the amount of data increases. So, all of those advantages make machine learning fraud detection system a better alternative to rule-based systems. So, one thing that I have heard from a lot of fraud teams is that they lack machine learning experts to help them build machine learning fraud detection system. They simply don't know how to start. So here is where AWS comes in. AWS has a way for you to kickstart your journey, regardless of your situation. So now we look on three different scenarios. On the first scenario, we assume that you have no data science experience. In that case, you can search on AWS for ready-to-use third-party solutions. So you will be able to quickly find a solution and integrate it with your system and be able to detect fraud in no time. This will significantly reduce your time to value. Then on the second scenario, we assume that your team has some limited data science experience. And in that case, they would like to experiment and build their own model. So in that case, you can experiment with Amazon Fraud Detector. So with just a few number of clicks, your teams, they will be able to develop their own model and start detecting fraud in no time. This will significantly reduce your development time. So in other words, Amazon Fraud Detector takes care of feature engineering, model selection, model fine-tuning, and model deployment. It takes care of the heavy lifting. And on the third scenario, we assume that your team has some dedicated machine learning team. So in that case, your machine learning expert, they would like to build their own custom model. So you can experiment with Amazon SageMaker, which is a fully managed service. So to sum up, regardless of your situation, you will be able to find a way in AWS to kickstart your machine learning journey. So let's now look on why we selected to use SageMaker in order to build like a machine learning fraud detection system. So Amazon SageMaker can assist you to build your model, deploy your model, and actually manage your model. So SageMaker has a lot of features that can assist your machine learning builders at every step of their model lifecycle, while at the same time make them 10 times more productive. So some of the SageMaker capabilities is that you have the ability to access your data wherever they are stored. So if you have transactional data or user behavioral data, you will be able to access them easily. Then, once you have access to your data, then the next step is to actually prepare your data. So you will need to clean your data, enrich your data, and bring them in an appropriate format before passing them to the machine learning model. And once you have them ready, then the next thing is to actually pass them to and feed your model. This will allow you to build a powerful model to more accurately detect your fraudulent activity. And then once you have your model, you can go a step further, fine-tuning, improve its performance in order to more accurately detect fraudulent activity. And lastly, developing and deploying your machine learning model can be fully automated end-to-end using SageMaker. So SageMaker is a really powerful tool if you are looking to start detecting fraudulent activities with machine learning. So at this step, I would like to welcome you, a special guest that we have here with us, and a really good friend of mine, Micha, who will take us through the journey that his company, Deutsche Bahn, went through to detect fraud. Micha, your stage is yours.
Thank you, Georgios. Hello. I have a question for you. Are there any fraudsters among us today? Okay, I can see one hand there. Just one fraudster? Nobody else likes to ride with the train for free? Okay. I was expecting more fraudsters to come, hoping to get a free training. We don't often offer this kind of education here. But all jokes aside, I of course won't be sharing any confidential information, but I will tell you what technology we use, how we use it, what were the challenges, and what we were focusing on. My name is Micha Železnikar, and I will tell you how we at Deutsche Bahn use machine learning to combat fraud. So most of you have already heard of Deutsche Bahn. We are the German national railway company, and if you came by train, that's us. With over 2 billion customers a year, we are the largest railway operator in Europe. But the focus of today's session is our web portal, bahn.de, or how we call it in Germany, bahn.de. This is where you can buy your train tickets online, either using your browser or with our mobile app, DB Navigator. With over 100 million tickets sold annually, this is the largest travel portal in Europe. And to put that into perspective, Every minute, we in average sell over 200 tickets. And at peak times, it's over 1,000 tickets. So throughout the session, our journey slides will show us where we are. Let me first introduce you to the fraud challenge. This is how our fraud system looked like before machine learning. We had a team of fraud prevention. Thank you. This is how our machine learning system looked like before machine learning. So we had a team of fraud prevention specialists and a rule-based risk engine. The fraud prevention specialists were in charge of a very complex set of rules, hundreds of them. And as we are typically dealing with professional fraudsters who adapt their techniques constantly, the challenge was that there was a lot of manual maintenance to keep up with the fraudsters. And the new building block we'll be talking about today is, of course, machine learning. The next step on our journey was to see if machine learning is the right approach for us. So we had some pretty strict requirements in mind. Obviously, there was the accuracy, because we wanted to catch more fraudsters than before, without blocking the good customers. Then there's the explainability. We need to be able to tell why a transaction has been blocked. Data privacy, that's a topic we take very seriously at our company. And there's the ethicality. People rely on Deutsche Bahn to get them to their destination for their mobility. And it's essential for us not to discriminate in any way. And many of you have probably heard that other companies have had quite a lot of problems with discrimination at artificial intelligence, especially if the part of the population has not been represented in large enough numbers. And that's something we definitely wanted to avoid. Then there's the responsiveness, which basically means we need to be able to react to new threats fast. That's something they also talked about on the previous slide. So, what were our challenges? As usual, we had a tight timeline. The first experiments started in October, and we wanted to have the results by the end of the year. Then there was the large learning curve. Because the project was something new for us, machine learning is known for its complexity, and our team has an engineering background with lots of infrastructure, with lots of DevOps experience, but we lacked some data science experience. We also didn't have an experimentation environment where we could experiment with the data. And we needed it if we wanted to prove business value with the data. So this is what we did. We staffed our team with 3 new additional data scientists to complement the existing engineering team. We got help from AWS. We had a 6-week prototyping engagement where Georgios was with us full-time, and that helped us to get up to speed with SageMaker. And importantly, we were putting the customer first. So let me explain that. My team, we developed the technology. And the fraud prevention team, they used the technology to combat fraud. And they were with us throughout the project. The before-mentioned approach worked well for us. We had a fully functional experimentation environment up and running within a week. In 2 weeks, the first model was trained. And most importantly, we were able to prove value using backtesting. So what's backtesting? Backtesting means using historical data to check how good the new machine learning model is. And at this point, it was already clear to us that machine learning is the right way for us to go. And after that was clear, we needed to gain trust. We needed to gain trust with the model, and we needed to gain trust with our colleagues who will be using the system. And as you'll see, there are quite so many building blocks to gaining trust. And ethical use of AI is one of them. And ethicality consists of several things. Privacy means that we strictly limit access to the data only to the people who really need it. And after the data is not needed anymore, we delete it immediately. Then there's the discrimination. And we're actually very conservative here. So if discrimination would be possible, we would avoid using such a feature. What's a feature in machine learning? A feature is an input parameter or a data point that is fed into the machine learning model. An example here would be name of the customer, price of the ticket, destination of the train, or something like that. And we would not use a person's first name as a feature. Because if somebody has an uncommon name, or maybe a name that is popular between fraudsters, we wouldn't want to discriminate because of that. What we might do, however, we might derive some statistical attributes from the first name. So, you know, on the QWERTY keyboard, if you like slide on it, and you go ASDF, so if somebody was to slide on the keyboard and do that, we would measure the distance between the keys, A to S, S to D, D to F, and we would get an average distance of 1, which is kind of suspicious. A normal name wouldn't have that. And that is the feature that we might use. Then there's the explainability, which basically means understanding how the model works. And that brings us to the next slide. Why is explainability so important? People depend on Deutsche Bahn for their mobility, and we must be able to explain why a decision has been taken. So let me share a story with you. An ambassador of a large non-European country wanted to explore the beauties of Germany with train, but couldn't book a ticket. And that made him kind of unhappy. So he complained, and my colleagues were able to explain why this has happened. And if this ever happens again, we need to be able to explain why, regardless of who the customer is. Let's get a bit more technical. The problem with machine learning is that it is often a black box. A black box that typically produces very good results, but users often don't understand how the results have been obtained. And this is where explainable AI comes into play. This is how our explainability dashboard looks like, with features and their weights. I explained previously what a feature is. It's an input parameter that is fed into a model, for example, name of the person, price of the ticket, or one of the features you can see here. So I would like to emphasize, these here are not real production features. I changed the name just in case any aspiring fraudsters today are taking notes. But the important thing to understand here is the logic behind it. For example, in this made-up transaction, somebody used Kali Linux to book the transaction. And Kali Linux is a known hacker operating system. He also used Tor to hide his IP, which is kind of suspicious. And even though he booked an ICE3, which is a train type that the fraudsters really don't like, that was enough for the machine learning model, combined with all the other features you can see here, to make a decision that this transaction is fraudulent. But it's actually more than just assessing single transactions in explainable AI. Explainable AI increases trust in the model and also improves understanding of the model behavior. Let's now let's take a look at how we evaluate the quality of the model, which is also important for building trust. It's a lot of text here, but once you know what to look at, it's easy to read. Okay? So to see how successful our models are, we use a tool that's called a confusion matrix. And in the upper left corner, we have true negatives, which are good customers that have been identified as good customers by the machine learning model. So all is good here. And then we have the true positives, which are fraudsters that have been correctly identified as fraudsters. All good here as well. And then we have the false negatives. These are the fraudsters that have not been identified. So we are losing money here. And then we have the false positives, which are good customers identified as fraudsters. And that are some unhappy customers. And this is actually how our real confusion matrix looks like, just with numbers on it. Which brings us to the trade-off, because there's always a trade-off. Decreasing false positives, which are the good customers identified as fraudsters, automatically increases the false negatives, which are the fraudsters that have not been identified. Or in other words, to decrease fraud loss, we sacrifice the user experience. So as a consequence, this is a balancing act between a good user experience for our legitimate customers on one side and limiting damage through fraud on the other side. And that's a decision the business decision makers should take. And we let the business decide. We provide the tools so they can find the right balance. There's again a lot of text here, but once you understand what to look at, it's easy. So the first thing to understand is that each transaction gets a score between 0 and 1. And this is the probability that the transaction is fraudulent. So a score with 90 would have a lot bigger probability than a score with 10 that this transaction is fraudulent, okay? And we then get to decide from what threshold on a transaction will be considered fraudulent. And we do it with the threshold slider, which simulates how changing the threshold changes the results. If we move the slider from 50%, which is on the left side, to 90%, which is on the right side, the false positives, so we still remember what are false positives? These are good customers identified as fraudsters. They drop drastically. In this made-up case, they drop from 100 to 5. But at the same time, the false negatives, which are the fraudsters that have not been identified, rise substantially. And in this case, they rise from 200 to 500. And with the slider, our colleagues can find the right trade-off and keep full control of the process. They get to decide. Okay, back to our journey. After the trust was gained, the next step was to go into the production. And when we were going to the production, we faced some challenges. Scalability, because at peak, we need to be able to process up to 1 million transactions a day, and they are unevenly distributed, so that makes it even worse. Then there's the reproducibility, because if we want to make a change to our system, we can't just roll it out in the production. We have different stages, we have different environments when we test that, and when we're happy with the results, we go to the production. And we ensure that the code and results are same in all environments using infrastructure as a code. Then there's monitoring and maintenance, because if something goes wrong, either with the infrastructure availability or a non-performing machine learning model, we want to know that as soon as possible. And there's the integration and deployment. The new machine learning system must work along existing systems and integrate with them. I will show you a diagram of our MLOps pipeline. It's a bit technical, but the main message I would like to convey here is automation. We merge many different steps into a pipeline, and we are able to execute that with one mouse click. So this is how our MLOps pipeline looks like. The payment backend exports data to data lake on a daily basis. And then we have an event trigger, which starts a Lambda function. The Lambda function then pulls the code from a GitLab repository and starts the SageMaker pipeline. The first step in the SageMaker pipeline is the pre-processing. And it takes the data from the data lake, processes it, and then the next step starts, which is training and evaluation, hyperparameter optimization. And after that is done, all together gets packed into a package and uploaded to the model registry. I hear many very capable data science teams do a lot of manual work and struggle getting their end products to their customers. The MLOps pipeline solves that problem for us because we can experiment rapidly, we can try out new things, we can easily change the code. And after we're happy with the results, we can deploy the new model with just a mouse click. So I think that the MLOps pipeline is also something where SageMaker really adds value, because everything is integrated and can be accessed from the same place. So to summarize all of this here, we automate all the steps here so that we can then execute them with one click. And it makes our life easier. Let me show you something also very interesting. It's our real-time inference architecture. And the challenge that we're addressing here is that a machine learning model is trained on a data snapshot, which can be days or even weeks old. And that means that the model does not have access to the current data. An example of that would be how many times a customer has booked a ticket in the last 24 hours. Or another example would be how many times a credit card has been used in the last week. So we use a little trick here to feed the real-time data to the model. And this is how we do it. When a customer initiates the transaction, the payment backend sends a request to the API gateway, which then triggers a Lambda function. A Lambda function then fetches the real-time data from the DynamoDB and pushes it into the machine learning model. Here where you can see SageMaker endpoint, that's the actual inference endpoint, there's where the model resides. And we push the real-time data to the model, and that increases the accuracy of the prediction. And after that is done, we write some data back to the database and send the result, which is now better than it would be without the data, without the real-time data, to the payment backend and to the customer. This was actually developed after everything else was already in place. And I mention this because our system architecture is not set in stone. It's flexible. So if we want to, if we need to, we can change it. To summarize all of this, we have an additional database to feed the machine learning model with real-time data. This increases the model accuracy because the model has real-time data. And I think that's a nice hack, actually. I was very happy when we implemented it. And that brings us to the key takeaways. What did we learn? We developed an amazing relationship with our our colleagues from the fraud prevention team. We understood their needs. They got to see what we can do for them. And as a direct result of that, there was the explainability dashboard and the threshold slider. The MLOps pipeline is also something that we would do again. It simplifies development and speeds up deployment. We got help where we needed it. We complemented our team with data scientists, and the AWS prototyping engagement kickstarted our SageMaker journey. And that brings us to now. What's next for us? In the fraud prevention field, we'll be adding new use cases, such as account takeover or voucher fraud. And we'll also be adding a graph database, which further increases the accuracy of the model. But we also have other very interesting projects. Currently, we're conducting a feasibility study for long-term train delay prognosis with explainable AI. So the idea here is to be able to predict train delays 3 to 7 days in advance, and also be able to explain why the delays are expected to occur. And we'll actually reuse much of the stuff that we developed in the fraud prevention project. An example here would be the threshold slider, because it enables us to focus on the trade connections with a high delay probability. And if you have the option to focus on the connections with a high probability of delay, that also increases the trust with all the stakeholders that will be involved in the project. Another exciting project is the GPT-like engineering of system logs. We have a lot of logs. Only at Bahn.de booking system, we log over 400,000 lines of logs a minute. So obviously that's a lot of logs. And if we can find something that will enable us to detect unusual events fast, we're more than happy to take it. These are two projects I'm personally very enthusiastic about, but also other teams at Deutsche Bahn have very interesting projects from various machine learning fields, from predictive maintenance up to visual damage detection. Last year, I attended the AWS Summit here in Berlin, looking for ways to kickstart our machine learning journey. And Florian from the AWS account team was teasing me, in a very positive manner, to be clear on that. But he was teasing me if I'm going to present at the 2023 summit. So I'm super happy that this has materialized. But as many of you know, Deutsche Bahn has some problems with punctuality. Last year was the worst year on record. So I would like to come here next year on this stage and share with you how we used machine learning to make the trains more punctual, to make the train come on time more often. And I need all the help I can get with this important challenge. So if you think you have what it takes and you're looking for a new challenge, we're always looking for great new colleagues. We have a very supportive environment for new technologies, and that big QR code you can see here, that's my LinkedIn. So contact me. Likewise, if you gathered relevant experience with your organization and want to share or exchange experience, the big QR code here, you can reach me there. Or you can come to me here after the presentation is over. So thank you, and now I will be handing over back to Georgios.
Thank you, Micha. Hello again. So, I would like to thank a lot, Micha. And one thing to mention, if you are unsure about joining the Deutsche Bahn team, I can only say one thing. I had such a great time working with the team. So, Micha mentioned that the mail system that was developed, it was the direct outcome of a prototype engagement that we ran together last October. So, I would like to pause here for a second and ask you to raise your hand if you know what the prototype engagement is. See a couple of hands. And may I ask a follow-up question? Have you actually run an engagement with us? I see very few hands. So, for you that you don't know what a prototype engagement is, let me answer that question for you. So, a prototype engagement is a real technical implementation of a solution to your business problem. So the solution is co-developed with your team over a period of a few weeks, and it follows AWS best practice. So our ultimate goal is to enable you to quickly explore new technology and see if they can actually help you solve your business problem. So an engagement has two stages. The first one is what we call the scoping phase. And this is where we sit down together, we look at your problem, and we define the scope. And this allows us, all of us, to be on the same page and work toward the same goal. And then the next thing is we also define what a successful outcome will look like in order to compare ourselves against it. The next step is what we call the execution and the handover. And this is where the magic happens. This is where we bring your solution into life. And then a typical engagement ends with a demonstration from your team to your stakeholders of the solution. And this is really important in order to get buy-in from your key decision maker. So, don't you want to be the next prototype success stories? Then speak with your account manager and we'll make it happen. So I assume that we have a lot of builders among us here today. So this slide is especially for you. So on this slide, we have tried to summarize some key links to help you get your hands dirty and start building your machine learning fraud detection system today. So we have here with us the whole account team. So if you have any question after the presentation, please feel free to come forward and raise it with us. We'll be more than happy to answer your question, and please don't be shy. So I would like to thank you all for your attention today, and I would like to ask you if you liked the presentation to provide some feedback. And if you didn't like it, then I would urge you to complete the survey. We value a lot your feedback and will make us be better the next time. So, as Johannes mentioned at the beginning of the presentation, companies lose on average 5% of their revenue every year due to fraud. So fraud never sleeps, but with machine learning, neither does detection. So what you are waiting for? Start building your machine learning fraud detection system today to protect your business from potential threats tomorrow. Thank you all.